I'd now like to introduce Jerome Chua, who holds a master's degree in food technology from Massey University. As part of the highly acclaimed longline bait project that he worked on as part of his master's, Jerome focused on transforming crayfish waste into sustainable longline baits. His work led to a highly successful outcome, garnering prestigious awards from Fisheries New Zealand and Seafood New Zealand for excellence in sustainable innovation within the seafood industry. Jerome.
Hi everyone, I'm really excited to be here. Before I begin, I'd like to thank BPA for inviting me to share my project, Sustainable POK Bait. Every year, heaps of crayfish are being thrown away, but what if we could turn it into something useful? Hi, I'm Jerome, and I spent the last year doing just that. A little background of myself before I start. I grew up in Singapore, and I did my bachelor's there. When I was done with my bachelor's, I told my mom, I'm gonna head to New Zealand on a working holiday visa. And little did I know, I would ended up on a fishing boat. And the first time I remember being on a fishing boat, I was chatting with Rob, one of the industry partners. And the first 5 minutes we were chatting. The remaining, I remember myself being at the side of the fishing boat, puking, looking at Mount Taranaki from afar. That was a beautiful sight. Yeah. So, here's the problem we have. Fallon Lobster Company faces unavoidable crayfish deaths, leading to a pile-up of waste, and they wanted to find a way to reduce waste. Rob, on the other hand, knew that rigs love crayfish, and he used the legs as baits, but other parts of the crayfish were still going to waste. To make full use of the crayfish waste, the head and the tail sections, Rob suggested mincing them finely and stuffing it into a sausage casing. But there was one big challenge. When it's submerged in the seawater, the mince would just disintegrate. That's when Venture Taranaki and Massey University came into the picture. They were looking for a master's student to take on this problem, and that's how I got involved. Here are the final 4 materials we have and we use in our project, and I'll elaborate on how we determine them. The first task was to figure out an appropriate binder to get the crayfish mince to hold its shape. For that, I reviewed papers, shortlisted several food-grade ingredients, and moved on to testing many. We tried a bunch of binders, roughly around 4 to 6, and even a combination of them because they might have synergistic effect. Eventually, I found one that worked. Next, I had to get the dosage right. Now for the fun bit, experiments. To test how effective the binders were in holding the bait, I submerged it in a container, you could see there, and it's filled with seawater, and it's attached onto an orbital shaker to mimic the sea turbulence. So I monitored the bait integrities every half an hour, and you could see from the picture, with and without the bait, that's the effect of the bait as it's able to hold the integrity of the bait. So now we found a binder that works. We had to move on to optimizing the dosage. So it's hard enough to withstand the baiting process, deployment process, and also being submerged in the sea for 6 hours. For that, I designed experiments to find the right hardness and tried different formulations. In this process of finding the appropriate binder's dosage, I made baits that were too soft. You can see on the video, it's really soft, squishy, and as we increase the concentration of the binder, it gets much tougher. So on the video, you could see it's quantified by the texture profile and analyzer in Massey. So it's hard enough to withstand all of these external forces. But we also made baits that were really tough. So as it gets really hard, it becomes really brittle. So when we hook the hook onto the bait, it broke the bait in half. So that's why it's important to find the right dosage for this. With the right hardness in place, I moved on to refining the bait for handling. For that, I explored different casing sizes and also the bait length. Some baits we made were too big or too long, and it didn't retain well on the hook after deployment. You can see from left to right, we decreased the casing diameter, and what was not shown in this slide was we also work on the bait length, ranging from 3 to 5 centimeters. So in the lab, I attached the bait onto the hook, and I was just trying to get it, like to see if it could withstand external forces. What was cut off after this video was I was swinging it like a lasso. Yeah. So after rounds of feedbacks and swinging it like a lasso, the fisherman and I were confident on the prototype, and we took it to sea trial. So to evaluate the performance of our bait, we carried out a sea trial using a long line fishing setup. We deployed roughly 2,500 baits in total, arranging them in a sequence of 50 test baits, control baits, 50 test baits, all the way until the line was filled up. You can see from the picture below, we deployed 3 different baits. One is the control, which is the cray legs, test bait A and B. From the table, we could see that there is a higher catch rate of fishes for the test bait A and B, 1% and 1.6%, and these fish species contain snappers, blue cords, and gurnets. The results also show that the test baits were more effective in catching rigs, and looking closer at test bait B, it achieved a higher total catch rate of 4%, which is double the amount that the control baits were catching. One of the observations we've seen is that the cray legs, the control baits were left on the hook, but then it was left empty on the inside, and it doesn't have any attractant properties. And being the scientist I wanted to understand why the test baits were attracting more fish. So I conducted a protein leaching analysis. So from the video, you could see that we submerged the bait in a container filled with seawater, and it was left shaking, and at every hour, I would take out a bit of water to quantify the protein content. You could see from the graph in the blue line, that's the test baits. You could see the baits were releasing double the amount of protein, which is what attracts the fishes. And that's why our test baits were catching more than the control baits. Looking at the bigger picture, we are really talking about closing the loop to balance the entire ecosystem. Our primary objective was waste valorization. So we used the underutilized crayfish waste stream, created it to baits, and by using these baits, we are targeting rigs. And when we target those rigs, we are preventing the rigs from overpopulating. When there is a healthy balance of rigs, we are actually protecting the crayfish stocks because rigs prey on them. And it's a full loop where we use the waste from the crayfish to ensure the survival of them. In conclusion, the sea sausage proved to be durable, effective, and sustainable. But this is just the start for us. We are currently working on scaling up and commercializing. And after working on this for a year, I believe that there are so many more possibilities of creating alternative baits using waste streams. I'd like to thank the huge team that make it this journey amazing and really fun for me. And thank you, BPA, for funding. Without you guys, I wouldn't be here, and I am enjoying my time here in New Zealand. Thank you. Thank you.
think it's one of the really lovely things about the BPA that we get to meet and see these amazing, talented young people. Gives me real joy. And we need all the joy we can get at the moment, I think. And yeah, lovely circular story, and I think a really great example of, that industry science connection really working so well together. Thank you, Jerome.